Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Lesson 7, Topic 2, Module 5, the angle measure of an arc. Mount Etna, a little eruption activity last week. Okay, here we go. All right, little volcano behind me. Nothing major. All right, okay, so opening exercise. If the measure of angle G, B, F is 17 degrees. So the first thing I'm going to do is label that. I'll make it red. So you start at G and you go up to B and then you go from B down to F. There is angle GBF. It is intercepting arc GF minor. So let me mark that. Here's arc. Oops, what is this doing? Hello. Arc GF minor is right here. Okay, and they're telling us that angle GBF is 17 degrees. Okay, so it says name 3 other angles that have the same measure and explain why. Well, if I move this down here and move this down here, then you can see GHF intercepts that same arc. So one angle is going to be angle GHF. Another one will be, I'll move this, whoops, on the end point, not the whole thing. I'm going to move this up to C and move this up to C. And as you can see, GCF intercepts that same arc. So GCF. So notice what's happening here. Any angle named starting with G and ending in F, or backwards if you did F something G, will all have congruent angle measures. So GCF, and then if I move it again to D, like so, move this over to D, sharing that same intercepted arc, therefore it's congruent. So angle GDF. It said to name 3, but there are 4, so I'm going to do one more. If I move this down to E and move this down to E, then you can see that GEF also shares that arc GF. So I'm going to say angle GEF. These are all 17 degrees because they share the same arc. Okay, now the next question says, what's the measure of angle GAF? Well, let's highlight it. So that is a central angle. Notice the end point of this segment is G. And then when I grab this one and bring that to A, GAF also intercepts that same arc. Now keep in mind, when you have an inscribed angle, the arc is twice the measure of the angle. So if this is 17 degrees, then this arc is 34. And central angles equal the intercepted arc. So I would say the measure of angle GAF equals 34 degrees because it is equal to the intercepted arc that GBF intercepts, and GBF is an inscribed angle, and inscribed angles are half the intercepted arc. Can you find the measure of angle BAD? Well, I'm going to use a different color for that. Or actually what I'm going to do is extend this. So watch what's going to happen. So BAF is a straight line going through the center. That's called a diameter. When the chord goes through the center, it's a diameter. And if I extend GA over to D, that too is a diameter. And now we have what are called vertical angles. So this angle here and this angle here are congruent. So since the measure of angle GAF is 34 degrees because the central angle equals the intercepted arc, then the measure of angle BAD is also 34 degrees because vertical angles are congruent. Okay, page 1. Okay, page 2, they give us circle O with points A and C on the circle. And it says, what if we started with an angle inscribed in the minor arc between A and C? So what we're going to do here is we're going to begin this by putting another point on the circle in between A and C, and I'm going to call that B. Okay, and then I'm going to take my protractor or actually a straight edge. Let's get a ruler and take your ruler and draw segment BC. So put your ruler on B and line it up with C like so. And I'll use green and draw a line through there like so. And then I'm going to rotate this around and I'm going to go through A the same way I went through B, like this. So now we have an inscribed angle that's obtuse on the circle. So the reason I have my ruler or my protractor, let's try again. The reason I have my compass here is because I'm going to label the intercepted arc using my compass. So I'm going to start right here, put it right on O like that, and I'm going to change it to red, and I'm going to trace the arc. Actually, let's make it thicker. I'm going to trace the arc around. That is the intercepted arc right there, from A all the way around to C. Okay? All right, so next thing we need to do is, okay, so the next thing we want to do is we want to measure an angle. So I'm going to draw, let's pretend I'm using my straight edge, but I'm not going to because it's easier for me on here. I'm going to draw, so you should do this as well with your ruler. Draw a segment OC, which is a radius of the circle, and draw the segment OA, which is also a radius of the circle. So there it is. Now what you need to do is get a protractor. And we're going to measure this. We want to see if this inscribed angle, though it's obtuse, is it half the intercepted arc? So I'm going to measure the central angle, and I could measure the outside one, but it'd be easier to measure the angle AOC inside. So using your protractor, line up 0 with OA, put the crosshairs at O. Okay, crosshairs right here at O. I might be off a little. I'm trying to be accurate here. So put that right on O and rotate so that 0 is right on OA. See how 0 lines up with that? And then I'm going to take and I'm going to look at where C ends up. So if I come over here, it looks like it's about 70 degrees. So that's what I'm going to label that. So I'm going to move this out of the way. And I'm going to label my central angle 70 degrees. Now, if you measure the outside angle, that should be 290 degrees. How do I know this? Well, 290 plus 70 is 360, and that's the full circle. So the exterior angle is then going to be, or this, not exterior angle, but the angle that's greater than 180, this large angle is going to be equal to the measure of that red arc. So this would be 290 degrees. Okay. So then if this is an inscribed angle, it should be half of that, and half of 290 is 145 degrees. So I'm going to use purple for that. So I'm going to put 145 degrees here, and then I'm going to check it with my protractor. So then I'm going to put my crosshairs of my protractor right on B, like so. Rotate it around so that my, let's see, I want my 0 line right on C. All right, so I'm crosshairs right at B. All right, crosshairs right at B. Try to be really accurate and rotate so that that's right on 0 right there. All right, one sec. Let me fix my, okay, there we go. So if I now click this and I open this up to over here, that is 145 degrees, just like we said. So that basically proves that even though the intercept or the inscribed angle is obtuse, it is still going to be half that major arc. That's what it's called, the bigger arc that's greater than 90. is or greater than 180 is a major arc. So major arc, and we can't call it AC. To name a major arc, we would need another point on it, like D, and then we'd say major arc, the measure of major arc, ADC. So you need 3 letters to name a major arc, and you have to have a point to tell the person who's starting to draw this, start at A, go to D, and then go to C. All right, and then the minor arc is just simply AC. So the measure of major arc ADC is 290 degrees, and the measure of angle ABC equals half of that, or 145 degrees. Okay, now it's an exercise, so pause the video, see if you can do these on your own, and then come back and see how you did. Okay, so now I'm assuming that you've done these, so I'm going to take a look at them. And it says in circle A, the measure of arc BC, the measure of arc CE, and the measure of arc ED, and the measure of arc DB equal 1, 2, 3, 4, 1 to 2 to 3 to 4. Find the following angle measures. So what I would say is BC is 1x, or simply x, CE is 2x, an unknown value, and ED is 3x, and DB is 4x. So I want to find x. Well, this is a full rotation of a circle, so I'd say x plus 2x plus 3x plus 4x equals 360 degrees. So x plus 2x is 3x plus 3x is 6x plus 4x is 10x. So if 10x equals 360 degrees, then x equals 36 degrees. So the measure of angle BAC, okay, now I'm going to label this angle BAC. It's a central angle. It is equal to x, because BC is x, and so that measure of angle BAC is 36 degrees. The measure of angle DAE, okay, so I'm going to rotate this around to here. DAE is right here, so that is intercepting the 3x. So the measure of angle DAE equals 3x, which equals 3 times 36, which equals 108 degrees. Okay, the measure of arc DB equals, and that's this arc right here, DB is right here, that's 4x. So the measure of arc DB equals 4x, which equals 4 times 36, which equals 72 times 2, or 144 degrees, or 108 plus 36. And finally, the major arc CED. Major arc CED, well, let me do it in green and I'll just expand it. Or actually, let me get rid of this one first. Major arc C, start at C right here, go to E and continue to D. Well, that equals this 2x and 3x. So that would equal 2x plus 3x, which equals 5x, which equals 5 times 36, which equals half of 360, or 5 times 36 is 180 degrees. So that tells us that DAC is a diameter. Okay, so there you have a quick exercise on angle measures from central angles and intercepted arcs. Page 3, more exercises. Pause the video again. Maybe you could do one at a time. Pause, unpause, check, pause, unpause, check. Here we go. I'm assuming you paused, and here we go. In circle B, AB equals CD. Okay, so this is a radius. This is a radius. I'm sorry, it's equal to the radius. This is a radius, and this is a radius. So we have an equilateral triangle. So this is 60 degrees. This is 60 degrees, and this is 60 degrees. There's our Q there. So the measure of arc CD is right here, and that is being intercepted by arc, or angle, angle CBD. which is 60 degrees. So the central angle equals the intercepted arc. So CD equals 60 degrees. The measure of major arc CAD, which is all the way around this way. Okay, that's the major arc that supplements. Would it be supplements? Adds up to 360. No, it doesn't supplement or complement. It adds up to 360. So if this is 60 degrees, then this is 360 minus 60, which is 300 degrees. So arc CAD is 300 degrees. The measure of major arc ACD, so let me get rid of these arcs, delete that and delete that. I'll leave the values, but now we're going to talk about starting at A, go to C, and continue to D. All right, well, this is a diameter, so that equals 180 degrees. All right, number 3, in circle A, BC is a diameter. The measure of angle DAC is 100 degrees. If the measure of arc EC equals 2 times the measure of BD, so let's do this. Here is EC. I'm going to call that 2x, 2 times something. Measure of arc EC equals 2 times the measure of BD. So then I'm going to name BD 1x. Does that make sense? If this is x, this is 2 times that. So there's the givens. Find the following angles of measure. Measure of angle BAE. BAE is right here. Well, this is a diameter. So let me draw this. BAC is a diameter. Okay, so a semicircle is 180 degrees. This is 100 degrees. So I'm just going to label everything I can see. If this is 100, angle BAD is 80 degrees because it's a linear pair, 180 degrees. So that makes X 80 degrees. And that makes 2X, 2 times 80, or 160 degrees. So if that's 160, then so is this angle here. So that is 160 degrees. Hopefully you're following this. And this is a linear pair. And so this little angle over here is 20 degrees because 160 plus 20 is 180. So I found all those central angles. 160 plus 100 is 260 plus another 100 is 360. And those should always add up to 360 at the center. Now let's answer these questions. The measure of angle BAE is right here. It's in green, equals 20 degrees. The measure of arc EC is 160 degrees. And the measure of major arc DEC, which would be, let's use purple, D all the way to B and continuing to C. Well, this is 180 and this is 80. So that equals 180 degrees plus 80 degrees or 260 degrees. Okay, number 4. Given circle A with measure of arc angle, with the measure of angle CAD 37 degrees, they labeled it for us. Find the following angle measures. I don't even look at this. I just try to answer all the questions first. It's good practice. So first thing I'm going to do is look at this minor arc, and it's equal to the central angle. So that's 37 degrees. Then I notice that I have an inscribed angle going from B to D and B down to C, and that intercepts our arc. So that angle's half. So half of 37 is 18.5 degrees. So this angle here is 18.5 degrees, half of the intercepted arc because it's inscribed. Okay, so we're looking for a major arc CBD. C all the way around to B to D. So the first one is asking for this. Whoops, let me try that again. The first one is asking for this major arc all the way around here, which is 360 minus 37. So I'm going to say that. It's 360 degrees minus 37 degrees, which equals 323 degrees. The measure of angle CBD, well, that's this one here, that is half that intercepted arc of 18.5 degrees. And the measure of angle CED, okay, that is this angle here. It is an obtuse inscribed angle. It's half of the intercepted arc of 323. So that equals 1/2 323 degrees, which equals 2 goes into 3 once, 2 goes into 12 6 times, 2 goes into 13 6 times with the remainder of 1, 2 goes into 10 5 times. So it's 161, not 6. Hang on. Let me do that again. 2 goes into 3 once, the remainder of 1. 2 goes into 12 6 times. And 2 goes into 3 1 time with the remainder of 1. 2 goes into 10 5 times. It's 161.5 degrees. Okay, page 4 brings us to the end of a nice short lesson 7. Review the lesson summary, the theorems and the relevant vocabulary, and go do your problem set.